All right, good evening. This is going to be my second try on this video, and hopefully I'm successful this time. Let's do a quick review of what we talked about in class on block day. A system of linear equations is a set of two or more linear equations. The solution of a system is an ordered pair that makes both equations true. On the graph of the equations, the solution is where the lines intersect. There are three possible relationships when we have two lines plotted on the same graph. For example, we could have the two lines intersect at one point, and this would be a system with one solution. We could have two lines that are parallel and do not intersect at all. So that means that this system has no solution. So a system with parallel lines has no solution. Then we could have a system of equations where the two lines coincide or lay one right on top of the other. These lines intersect at every single point, so we say that the system has infinitely many solutions. So when the two lines are the same line, the system has infinitely many solutions. We are going to be graphing lines and then using the graph to find the solution to the system of equations. Before we graph our lines, we're always going to want to make sure that they are in slope-intercept form. So these are the steps that we're going to follow. The first step is going to be to write the equation in slope-intercept form. In this section, the equation is already in slope-intercept form. We know that because both equations are solved for y. And then we're going to graph both lines on the same coordinate plane. Let's first identify the slope and y-intercept of each line. This line has a slope of -3 because the -3 is in front of x. The y-intercept of the line is 4. So we have a slope of -3 over 1 and a y-intercept of 4. This line has a slope of 2/3 and a y-intercept of -7. Let's graph the first line. We'll start with a y-intercept of 4, and then we'll use our slope to find other points on the line. So we'll go down 3 and right 1. We could also go up 3 and left 1. To graph the second line, we would start with a y-intercept of -7. Our slope is a positive 2/3, so we would move up 2 and to the right 3. We can see that these two lines intersect at one point. Their intersection point is 3, -5. So 3, -5 is the solution to this system of equations. Okay, let's go down and do an example of this together. So the first thing we will do is we will make sure that our lines are written in slope-intercept form. Both of these equations are solved for y, so we're good. Now we'll identify the slope and the y-intercept. The slope of the first line is 1. The y-intercept is -4. I'll use red for the second line. The slope of my second line is -2, and the y-intercept is +5. Now I'll go back to blue to graph the first line. Start with the y-intercept. So we start at -4 on the y-axis. Our slope is 1, so we'll move up 1 and to the right 1. And I'm going to go ahead and graph lots of points because the more points I graph, the easier it will be to see the solution, to see the point where the two lines intersect. Okay, lots of points. All right, now I'm going to switch to red and graph the second line. The y-intercept of the second line is 5. My slope is -2 over 1, so I will move down 2 and right 1. And I'm going to keep up that pattern, down 2 and right 1. And I notice that these two lines intersect at this point right here. I'm just going to finish my lines. And the solution to this system of equations is going to be this point right here, which has an x-coordinate of 3 and a y-coordinate of -1. We're going to leave problems 2 and 3 to work on together in class. So turn over to the back of your paper. Now we're going to go through an example of graphing a system of equations where y is not alone. So the first thing we are going to have to do is to solve the equation for y. So let's see how they did that in this example. The first thing that they did was to move the x's over to the other side of the equation. So we're going to subtract 4x on each side. Then we need to bring everything down and divide both sides by 2. So divide everything by 2. Then we'll need to simplify. -4 divided by 2 is -2. So the first term becomes -2x. -2 divided by 2 is -1. So our equation is y equals -2x minus 1. This line has a slope of -2 over 1 and a y-intercept of -1. Let's look at our second line. First step, move the x's to the other side of the equation by subtracting 3x. Bring everything down and then divide everything by -2. After we simplify, we will get y equals 3 over 2x plus 6. Both of these terms turn out positive because we are dividing two negatives. -3 divided by -2 is positive 3 over 2. -12 divided by -2 is positive 6. So the slope of this second line is 3 over 2 and the y-intercept is 6. Now we're going to go ahead and graph those lines, and we'll see that the solution is the point -2. It looks like they wrote -2, -2, but it should actually be -2, +2, because this point is above the x-axis. All right, so let's do an example on our own. Remember, the first thing that we want to do is check the equations to see if they are solved for y. Our first equation is solved for y. Our second equation needs to be solved for y. I'm going to rewrite it over here. The first step is always going to be to move the x's to the other side. So that gives me y equals -6 minus 2x. This equation is now solved for y, and we're ready to graph the two lines. So the slope of our first line is 3 over 1. Our y-intercept is -1. The slope of our second line is -2 over 1. And our y-intercept is -6. Starting with the y-intercept of the first line, we're going to graph a -1 on the y-axis. We have a positive slope, so we will move up 3 and to the right 1. And again, graphing a lot of points so that it makes it very easy to see where the two lines intersect. Okay, so here's our first line graphed. Now we'll graph the second line. Our second line has a y-intercept of -6 and a slope of -2. So we're moving down 2 and right 1, or up 2 and left 1. And we have discovered our intersection point, so we'll circle that. And we'll write the coordinates of the point of intersection. The coordinates are -1, -4. Okay, one more example. We're going to tell whether the ordered pair is a solution of the given system. So we want to know if the ordered pair 4, 1 is a solution to this given system of equations. If it is a solution to the system of equations, it will make both of the equations true. So we need to plug in 4 for x and 1 for y in each of the equations and then simplify. So let's do the first equation. So 4 plus 2 times 1 equals 6. 2 times 1 is 2. 4 plus 2 does equal 6. So because the two sides are equal, we know that the point 4, 1 is a solution to that system. Now let's look at y equals x minus 3. So we're going to plug in 1 for the y, and we're going to plug in 4 for the x. We simplify the right side, and when we simplify the right side, we see that both sides equal to 1. So the point 4, 1 is a solution to this system because it is a solution to both equations. It makes both equations true. If it does not work in one of the equations, it is not a solution. It has to work in both. Okay, that's all until class on Friday.